Welcome, detectives. Today, we are on a mission to crack the code of geometry. And forget those boring lessons, okay? Think of this as your ultimate guide to understanding the very structure of the world around us. I mean, from massive skyscrapers to tiny scientific diagrams, lines and angles are the secret language behind it all. So you ready? Let's get into it.
So here's our game plan, our detective's roadmap, if you will. We're going to start with the angle playbook to get the basics down. Then we'll investigate what happens when lines cross. After that, we'll get our big break with parallel lines and transversals. We'll use all that to solve a big geometry puzzle, see how it all connects to triangles, and then finish up with your very own geometry cheat sheet.
All right, every good detective needs a playbook, right? A guide to the absolute fundamentals. Well, that's what this first section is all about. We're going to master the basic types of angles, because trust me, these are the essential clues we're going to use for the rest of our investigation.
Okay, this is our core vocab. You've got to know this stuff. An acute angle, that's the small, sharp one less than 90 degrees. A right angle is that perfect corner, exactly 90. Obtuse angles are bigger, between 90 and 180. A straight angle is, well, it's a straight line, 180 degrees. And then you've got the big one, the reflex angle, which is more than 180. Getting these down is totally non-negotiable.
Now, let's clear up something that trips a lot of people up: complementary versus supplementary angles. It's actually pretty easy. Complementary angles are two angles that team up to make a right angle, so they add up to 90 degrees. Just think C for corner. Supplementary angles team up to make a straight line, adding up to 180. Just think S for straight. Easy, right? All right, pop quiz. Let's test those new skills. What is the supplement of a 74-degree angle? Go ahead, hit pause if you need a second to think about it. You got it? So, since we know supplementary means they add up to 180, all we have to do is take 180 and subtract 74, which gives us 106 degrees. Just like that. Okay, playbook mastered. Now for our first real piece of detective work. What actually happens when two straight lines cross over each other? This simple little intersection gives us some incredibly powerful clues we can use to solve much, much bigger problems. So when two lines cross, they make a perfect X. The angles that are directly across from each other in that X, those are called vertically opposite angles. And here's the key, the big secret from Theorem 6.1. They are always equal. This is a total game changer. You're going to use this one all the time. So how do we know they're equal? Well, it's not magic. It's just pure logic. Let's walk through it. First, look at angle AOC and angle AOD. They sit right next to each other on a straight line, right? That makes them a linear pair, which means they add up to 180 degrees. Got it? Okay, step 2. Now look at angle AOD and angle BOD. They also form a linear pair on the other straight line, so they also add up to 180. So if both pairs equal 180, they have to be equal to each other. That's step 3. And for the final step, we just subtract that common angle, AOD, from both sides, and bam, it proves that angle AOC has to equal angle BOD. See? It's brilliant. This is it, everyone, the big break in the case. When a line, which we call a transversal, cuts across two parallel lines, it creates a whole set of relationships that are super predictable and reliable. I'm telling you, mastering this is the key to unlocking pretty much any geometry puzzle you'll ever face. Now, this intersection creates a bunch of important angle pairs. You're going to see a few names pop up here: corresponding, alternate interior, alternate exterior, and consecutive interior angles. But don't panic or try to memorize them all at once. We're about to focus on the key relationships that are actually going to help us crack the case.
And here are the 3 big ones you really need to know. When those lines are parallel, corresponding angles, which are in the same spot at each intersection, are equal. Alternate interior angles, which are on opposite sides of the transversal and kind of tucked inside the parallel lines, they're also equal. Now, the one that's a little different is consecutive interior angles. They're on the same side and inside, and these two add up to 180 degrees.
Now for a huge exam tip. Think of this as a two-way street. We know that if lines are parallel, then corresponding angles are equal. But according to Axiom 6.4, it also works the other way around. If you can prove that a pair of corresponding angles are equal, then you can state for a fact that the two lines are parallel. That's a powerful tool. Okay, we've gathered all our tools, we've collected all the clues. Now it's time to put it all to the test and crack the final case. This puzzle might look a little complicated, but trust me, we have everything we need to solve it. And here is our challenge. We've got 3 parallel lines, sliced by a transversal. Our job? Find the values of x, y, and z.
All right, let's get to work.
Looking at this, I get it. It's easy to feel a little overwhelmed. There's a lot going on. But the key is not to panic. We just need to find one little foothold, one relationship to start with, and the rest will fall into place, like dominoes. I promise.
Let's just follow the logic one step at a time. First, let's find y. The lines CD and EF are parallel, right? That makes y and the 55-degree angle consecutive interior angles. And what do we know about them? They add up to 180. So y is just 180 minus 55, which is 125 degrees, one down. Next up, x. Lines AB and CD are parallel, and x and y are in the exact same spot at each intersection. They're corresponding angles, which means they're equal. So if y is 125, then x is also 125. Two down. Last one, z. Now we know AB is parallel to EF, and we're told EA is perpendicular to AB. That means angle EAB is 90 degrees. Angle EAB and angle FEA, which is just z plus 55, are consecutive interior angles, so they have to add up to 180. That means 90 plus z plus 55 equals 180, or z plus 145 equals 180. A little bit of subtraction, and we find that z is 35 degrees. Case solved. So you might be wondering, what's the point of all this? Well, our detective work on parallel lines actually lets us prove other really important truths in geometry. Let's see how this all connects to one of the most famous shapes out there, the triangle. Here it is, one of the most famous rules in all of math. The three angles inside any triangle always add up to 180 degrees. And guess how you can prove that's true? By drawing a clever parallel line and using what we just learned about alternate interior angles. You see, all these concepts are connected. We've cracked the case, but before you head out, let's put together the ultimate cheat sheet. This is your detective's handbook, a quick summary of the essential rules you're going to need for any geometry case you have to solve from here on out. All right, here are the absolute must-knows. A linear pair on a straight line adds up to 180. Vertically opposite angles are always equal. When a transversal cuts parallel lines, remember, corresponding are equal, alternate interior are equal, and consecutive interior add up to 180. And of course, the angles in a triangle add up to 180. This is your toolkit. Master it. And here is the most important exam tip of all. I'm serious. It's not enough to just get the right number. You have to prove how you got it. For full marks, you have to state your reason, because they're vertically opposite angles, or by the linear pair axiom. Show your work. Prove your case. So remember, geometry isn't about memorizing a bunch of boring rules. It's about learning how to see the patterns, how to read the clues that are all around you. You are now officially equipped to be a geometry detective. So the only question left is, what case are you going to solve next?